He already knows it's going to be like
All right, we're looking at two things today. We're looking at problems that deal with arc length, and we're looking at problems that deal with area of a sector. And to be able to deal with these two, we need two new formulas. So write these formulas down, please. We have S equals R theta, and we have A equals 1/2 R squared theta. S equals R theta, and A equals 1/2 R squared theta. The S stands for arc length, the R stands for radius, and theta stands for the angle. On the second one, the A stands for area, R again is radius, and theta again is my angle. Now, something that is very important when you use these two, theta must be in radians. Theta must be in radians for these formulas to work. Your angle must be in radians. So what happens if they give you a problem and they give you the angle in degrees? Very good. You got to convert it to radians. So S equals R theta for arc length. S is your arc length. R is your radius. Theta is your angle. A equals 1/2 R squared theta. A is your area. R is your radius again. And theta is your angle again. So we'll start off by looking at number 29. So they're giving me 5 pi over 12. And they're giving me a radius of 4 yards. The directions on this section say find the length of the intercepted arc, given the central angle and the radius. So there's really not much to this problem. So I have S equals R theta. S is what I'm looking for. My radius is 4, and my angle is 5 pi over 12. Then we want to punch that in our calculator. So we're going to go 4 times 5 times pi divided by 12. So new document. I don't want to save it. Calculator. So I want 4 times 5. What, is that what it was?
Yeah.
Times pi. And then divided by 12. That gives me 5.235. So S equals 5.235. Now, what are my units? Because I'm very unit driven on what we're doing today. You've got to put your units in there so you know what it is you're talking about. So what's my unit? Yards. Somebody explain to me why yards make sense. Raise your hand. Somebody raise your hand and explain why yards make sense. You gotta give me more than that. I need more than that. Kurt?
So the radius is proportional to the circumference.
Not what I'm looking for still. What is it we're finding? We're finding arc length. So since it's arc length, that means I need a unit that measures length, and that's why we choose yards, because yards is the unit in this problem that measures length. That's what I want. That's the thought process I want you guys to think about. Okay, I want you to realize what is it I'm finding, and what type of unit goes with what I found. That's what I want. All right, next one. 31. We've got 45 degrees, and we have a radius. What does it say? 5 miles. So I have 45 degrees, and I have a radius of 5 miles, and I want the arc length. So S equals R theta again. S is what I'm looking for. My radius is 5. My angle is 45. Are we happy with that?
No.
Why not?
It
It has to be in radians. So what do I need to multiply by to make it to where it's in radians? 5 over 180. Matthew.
Can you multiply 45 by 5 and then do the? Oh yes, you can. That's what we said about this. Okay, never mind.
Okay. So then I can do all this at the same time on my calculator. So I'm going to do 5 times 45 times pi and divided by 180. Press enter. We get 3.926.
Oh.
And my units?
Miles.
Miles. So somebody explain to me what we're finding in 3.926 miles. AJ?
Distance.
Okay, what type of distance?
The distance between the, or the distance of the arc length.
Distance of the arc length. Very good. We're finding the distance of the arc length. So if I've got a radius that is 5 miles, and then I rotate this thing 45 degrees, the distance that is covered right here is that 3.926 miles. That's what we're finding. Okay. Very good. All right, next one is number 43. This time we're looking at area of a sector. The directions say find the area of each sector. So we're wanting the area of that highlighted region there. So if I'm finding area, that means I need the area formula. Area equals 1/2 r squared theta. So I'm finding area. Area is what I'm looking for. I've got 1/2. What's my radius? 1.5 squared. My angle is 102. Are we happy with that? No, I need to do what else? Multiply by pi over 180. Then I can punch all that in at the same time. Alright, so instead of 1/2, what's something easy to put in there except for 0.5? So I'm going to do 0.5 and then I'm going to do 1.5 squared. And then I'm going to do, was it 102? And then times pi. And then divided by 180. And we get 2.002. Alright, what about the units on this one? Inches squared. Kendrick, why inches squared?
We're doing area.
We're doing area, and area's units always need to be squared. So we get inches squared. Which problem? You didn't get it on your calculator?
Yeah, I probably put it in wrong though.
Let me see it. You put in 105 instead of 102. Okay, next one.
Wow, that's a lot easier.
Kind of an application problem on number 49. Says we have a dartboard shown is divided into 20 equal sectors. If the diameter of the board is 18 inches, what area of the board does each sector cover? So as you can see in red, we want to know how much area does each piece like that cover. So if we're looking for area, we need area equals 1/2 r squared theta. Okay, and it should be fairly easy to figure out what r is. What does r need to be?
9.
9. Why 9, Laura?
Because the diameter and radius is diameter divided by 2.
Okay, so diameter is 18, so if I want the radius, I've got to divide by 2. So that's where we get 9. Okay, Bobby, what about the angle? What about the angle? What do you think about the angle? Doesn't say the angle, but it gives me some information on how to find the angle. They're all equal to each other. So if they're all equal to each other, and there's 20 of them, what can I do to find the angle? Carson, can you help her out?
Would you find the circumference and the half?
What do you think, Christian?
I think we have to get this sample.
Very good.
Yay, for sure.
So all the way around is 360 degrees. there are 20 of them, so I'm going to divide 360 by 20. What is 360 divided by 20?
18.
18. So that section is 18 degrees, but I don't want it in degrees. I want it in radians, so I'm going to stick on the pi over 180 in there. And then that will tell me the area of that sector right there. So we've got 0.5 times 81 times 18 times pi and divided by 180. So we get an area of 12.723. And Matthew, my units need to be
Inches squared.
inches squared. Very good. So we figured out that each section that we have colored in there covers an area of 12.723 inches squared. Very good. Alright, this time, this is 59. It says find the measure of angle theta in radians and degrees. So they've given me some information to help me figure out what theta needs to be. So which of my two formulas, bless you, which of my two formulas do I want to use? Arc length, why?
What is the
You gotta be confident.
Wait,
What is a 15? Great question. AJ?
that's the arc length.
Hey, 15 is the arc length. So they've given me the arc length, and what else did they give me?
Radius.
The radius.
So,
So I'm solving for theta, so which formula do I want?
arc length.
I want the arc length formula. So S equals R theta. Bless you. I plug in 15 there, I plug in 4.5 there, and theta is what I'm searching for.
Divide by 4.
I would divide, so I need 15 divided by 4.5. 15 divided by 4.5. So 3.333. And what about my units on this one?
Feet. Degrees. The radian.
Radians. Lauren, why radians?
Because you said it had to be radian. I really don't know.
Okay, if you're gonna give me an answer, you gotta be ready to tell me why. But she's correct, even though she wasn't confident. Whenever we're dealing with these formulas, what do we say the angle is always measured in? Radians. So that is why it's in radians. Okay?
Doesn't make sense.
And yes, obviously 3.33 degrees. Yeah, we're way bigger than that. So now it also wants it in degrees, so what do I do to get it in degrees?
You multiply by 180.
Oh.
Multiply by 180 over pi. Now, I suggest using the full decimal to get the most accurate angle in degrees. So all I have to do is go times 180 and divided by pi, and that will give me my most accurate answer. And press enter. We get 190 point, and I only want it in to the 10th, so 190.9 is fine. Does 190.9 make sense?
Yeah.
Why?
Because it's over 180.
Because it's past 180. Yes, it's past 180, so it needs to be bigger than 180. My angle is bigger than 180, so we like it. All right, one more example. Turn the page to 240. We're going to look at 63.
Got it.
No? Is it? Alright, it says a pulley with radius R is being used to remove part of the set of a play during intermission. The height of the pulley is 12 feet. If the radius of the pulley is 6 inches and it rotates 180 degrees, how high will the object be lifted? So as you can see here, I've got this, and they're saying if I take this and I rotate it 180 degrees, how high will that thing move up? Is what they're wanting to know. So how do I figure that out?
Does the 12 feet matter?
That's a great question. Does 12 feet matter?
Probably.
No.
That's
Sure.
great.
Because you're just looking for the length of.
I'm looking for the arc length is what I want.
Okay.
Because if however much this moves around my pulley is how much this thing is going to go up. So that's all I'm looking for is arc length. So I need S equals R theta. What's my radius?
Did they give it to us?
6 inches. And my angle?
180.
180, but I want it in radians. What's 180 in radians? You better know that conversion. It's just pi, right? So I can just stick pi in there. So I multiply that, 6 times pi should be just over what? Just over 18.
Yep.
So 6 times pi, I press enter, 180 or 18.849. 18.849. My units on that?
Inches.
Inches.
They do want that in radians.
No, but it's not the angle.
So if I take that pulley and I rotate it 180 degrees,
Ah.
if that pulley is 6 inches, it will raise whatever I'm raising up 18.849 inches. Okay. Let's try the second part. Next thing says, this time, what if the pulley is of radius 4 inches, and this time we want to rotate it 900 degrees? How high will the object be lifted? So S equals R theta. This time my radius is 4. This time my angle is 900. What else do I need? Pi over 180. And we punch it in. So 4, 900 pi divided by 180. So 4 times 900 times pi and divided by 180. So 62.831 inches. Okay, but what's something else I might want to know? Because 62.83, yeah, I might want to know how many feet that is. So what do I do to my answer to figure out how many feet that is? Divide by 12. So I'm going to go back in here and I'm going to divide my answer by 12, and that gives me 5.235 feet. So that's the same thing as 5.235 feet. Okay, so if you got a pulley, and you know what the radius is, and you know how much you're going to rotate it, you can figure out how much or how far whatever you're lifting is moving. I think that's pretty interesting. Okay, so that is arc length and area of a sector. The main thing we've got to be able to do when we're using these formulas is understand what has to happen.
Yeah, whenever radius.
I've got to have my angle in what form? Radian measured. My angle must be in radian measured. If you screw up on these problems, it's usually because you forget to change your degree to radians. All right, Simon's over here on the board. Number 5. 10 problems. Yes.
So if it's in degrees, you just automatically have to change it to
You automatically have to change it to radians. That is correct.
Started